Good evening everyone. So recall that in the last class we have seen how do we solve a homogeneous system of equation with constant coefficient. A non-homogeneous system of equation looks like as given in equation 1 where we have the non-homogeneous part f1 of t and f2 of t. Now if you recall the second order non-homogeneous differential equation, then we used to write that its general solution is y of x, which is yp plus yg, where yg is the general solution of the homogeneous part and yp is the particular solution of non-homogeneous part. The same thing we are going to do here also to compute the general solution of non-homogeneous system of equation. We will compute the general solution of the homogeneous part. So equation 2 represents the homogeneous part, and we will find a particular solution of non-homogeneous differential equation, which is equation 1, and add them. That gives us the general solution of non-homogeneous linear system of equation. So theorem says that if two solutions of equation 2 are linearly independent, and if x is equal to xp of t, y is equal to yp of t is a particular solution of equation 1, then yg plus yp, so which means the general solution of 2 plus the particular solution of 1 gives you the general solution of 1. So now the question comes, how do we find the particular solution? Again, in case of non-homogeneous second order differential equation, there were different methods, but one of the method was variation of parameter. So in variation of parameter, what we used to say that if yg is c1 y1 plus c2 y2, which means it is the linear combination of y1 and y2, then I want yp to be linearly independent from y1 and y2. It means linearly dependent means one is a constant multiple of the other. So if yp, if you write yp in the form of c1 y1 plus c2 y2, then yp is linearly dependent on y1 y2. To be linearly independent, you want yp to be a non-constant multiple of y1 y2. It means v1x y1 plus v2x y2, and then we used to compute the value of v1 and v2. Similarly, to find the particular solution using method of variation of parameter, you compute the general solution of homogeneous part and replace c1 c2 by the non-constant functions of t. So if this is the general solution of the homogeneous part or general solution of equation 2, then xp yp would be replace c1 c2 by v1t v1 v2t, which gives you the particular solution of the non-homogeneous equation. Okay, things would be clear once you see this example. So I need to find the general solution of this non-homogeneous system of equation. To find the general solution, first I consider the homogeneous part, which is this one, find its general solution. This problem, finding the general solution of this equation 2, has already been done in the previous lecture. So general solution comes out to be given as equation 3. Now for the variation of parameter, I replace c1 by v1t and c2 by v2t. So this is how the particular solution looks like. Now the question comes that how do we find the value of v1t and v2t? Yes, think over it. The idea is simple. Since the solution looks in this form and it is the solution of equation 1, it means it must satisfy equation 1. So I will put equation 4 into equation 1. Yes. So put equation 4 into equation 1 and see what you are getting. Substituting 4 into 1 and see what you are getting. So 4 is dx by dt. So that gives you v1 dash, because v1 e raised to the power minus 3t is there. So v1 dash e raised to the power minus 3t minus 3 v1 e raised to the power minus 3t. Similarly, v2 dash e raised to the power 2t plus 2v2 e raised to the power 2t, and then minus 3v1 e raised to the power minus 3t, because left hand side is x plus y. So if you do x plus y here, you will see that v1 minus 4v1, that gives you minus 3v1. Similarly, both the sides are v2 v2, so you will get 2v2, and then minus 5t plus 2. Okay, now if you simplify it, then v1 term and v2 term would cancel out both the sides, and this equation becomes v1 dash e raised to the power minus 3t plus v2 dash e raised to the power 2t is 2 minus 5t. Similarly, from the second one, we will get minus 4 v1 dash e raised to power minus 3t plus v2 dash e raised to power 2t is equal to minus 8 minus 8t. I will call them as equation 5a and 5b. Now, only one observation here is that you will realize that when I got 5a and 5b, they don't have any term of v1 and v2. Even if they have the term of v1 and v2, then we cannot solve it, because right now it becomes a non-homogeneous system of equation with two unknown variables v1 dash and v2 dash. It can be easily solvable. But if it have, for example, v1 e raised to power minus 3t, then we cannot solve it. But technically there would not be any term of v1 and v2. Why is it so? Because when you are considering the solution, for example, if you are considering c1 e raised to the power minus 3t, and if you replace c1 by v1 e raised to power minus 3t, its differentiation is minus 3 c1 e raised to power minus 3t, and its differentiation is v1 dash e raised to power minus 3t minus 3 v1 e raised to the power minus 3t. So it means that if v1 is a constant, then these two terms would be there. The extra term is v1 dash. And now when v1 is a constant, then this particular solution would become linearly dependent on y1 y2, which means that it would be the part of the homogeneous, it would be the part of the solutions of the homogeneous equation. It means it must satisfy the homogeneous, and in case of the homogeneous equation, the right hand side is 0. That's why all these terms where you have v1 v2, they are the part of the homogeneous system and they becomes 0. The only term which contributes to non-homogeneous part is v1 dash and v2 dash. That's why you have v1 dash and v2 dash. Now moving further, I just need to solve them. So if I subtract 5a minus 5b, I will get an equation in v1 dash. And if I substitute v1 dash into equation 5a or 5b, I will get v2 dash. Integrating v1 dash and v2 dash, I will have v1 and v2. Please try to do all this calculation by yourself. The idea is very simple. The only mistake which can happen is only in the calculation. Once you have v1 and v2, then you will put it back into equation 4. So this is equation 4 where you have to substitute the value of v1 and v2, and after substituting it, you will get a particular solution where xp is 2 plus 3t and yp is 2t minus 1. So idea is very simple. This is the only method which you will study to solve the non-homogeneous system of equation with constant coefficient. There is an exercise for which I have already provided a solution, and you can see many more exercises from the book.